other administrators use it. There's some type of technology there that's web-based that integrates with the PBX. So just a real quick overview of cross-site scripting. There's a few different types. There's stored and there's reflected. Stored is where I could send the arbitrary JavaScript to the web server, and it stores it in a database, and it could be reposted, kind of like a forum. If I put a script source include in a forum, everyone who looks at the post will run that JavaScript. That's a stored. A reflected is I bounce it off of something. So say I send you an email, and you click a link, and that link includes this JavaScript code. It's kind of a one-shot compared to breadth and width comparatively. So it's tough to see, but he is a ninja, but you can't see him. So for me, what I'm going to show you, it's kind of neither, in my opinion. It's more directed. So say, for example, as me, the attacker, I know, based off of the user agent from your PBX, I know the version of the system you're running. Possibly there's additional information to show me what kind of web application you're using. And since a lot of this is open source, I could test it offline, find a vulnerability, and then launch it against you. So say as me, the attacker, I know you have this administrative logging infrastructure. I don't need to know the administrator. I don't need to know anything about this person. Just I need to presume that this is going to be checked. These logs are going to be checked through this web application. So I'm basically directing an attack towards the administrator. I don't need to know anything else about the person. It could be a robot from outer space. It really doesn't matter. So this is basic information for you guys. All right, so this is some sample attack scripts. You got the script alert123. That's a proof of concept. So if you're browsing a web application, I put input in there, and all of a sudden I get this pop-up box, 123. It's a proof of concept that I just executed JavaScript. So say, for example, example.com ID equals, and then you throw that cross-site scripting in there. So ingress and egress filtering. A lot of web applications, if they are vulnerable to this input validation issue, cross-site scripting, they'll fix it on the ingress. So say, for example, they'll filter it before the information is processed, but then that information is returned back to the server and it's sanitized. It doesn't actually include the raw brackets or just whatever filtering mechanisms they use. So that's on going into the system. Coming out of the system, that's typically not fixed. If for some reason you could get into the database, put in the JavaScript, and then load the page, there's no filter on the way to the client. So typically that's just the way it goes. There's no filtering towards the client. So I'm going to paint a picture for you guys. So say, for example, you have a server, and the only port that's publicly facing is 5060 with SIP. Internally, within the core network or the DMZ, or however the architecture is set up, internally you could access additional resources like a web server, but it's running on the same box. So as me, the attacker, how do I target the web application that I can't even communicate with? It's kind of a conundrum. Just the way I phrase it, I do it purposely to make it sound tricky. So how do I attack a service I can't communicate with? Well, the service I'm trying to attack, I can't access that port. I can only access SIP. I can't access 80 or 443. No. Well, you were right, but you should have stopped at that. So basically, there's a way in which I could include this JavaScript in a SIP packet. And then the SIP packet, through the logging infrastructure, gets processed, and an administrator looks at the website, and all of a sudden you get this 123 alert box. That's being nice about it. That's a proof of concept. Otherwise, in a real attack situation, Payload would be, add an extension with this password, this username. So all of a sudden, an administrator just innocently looking through their logs, and unbeknownst to them, they're being targeted, they're being attacked. Their browser's actively executing code. Is anyone familiar with web application firewalls? A WAF, or whatever they call them. So a web application firewall, basically it sits in line, kind of like a load balancer or a proxy, and all it does is try to detect malicious input. So say, for example, you put this script alert 123 in there. This web application firewall will read this and look at it, detect it that it's an attack, filter it, drop it. There's certain mechanisms that would prevent the website from actually being exploited. So for me, SIP and HTTP are very common. They're basically cousins in a sense. If you just look at the raw request headers, the content itself, they're very similar. You got your register, you got your get. You got your SIP / version number, you got your HTTP / version number. You got your content length headers. Very, very similar. So web application firewalls at this point can't inspect a SIP packet for web-based vulnerabilities. So there's really, other than testing your software to ensure that the web application filters this egress, on the egress filtering, there's really nothing you could do. You can't buy a box, you can't put it in place. Basically, you just have to have a secure website. So, I'm going to show you guys some code. All right, just going to run through this real quick. So, I'm a Perl fan. Who likes Perl? Okay, you're all my friends. The rest of you guys get out. So I wrote this fuzzer. I put one base SIP packet in it, and it generates. Last time I counted, it was like 14 million packet combinations, just one-off pre-authentication packet combinations, and it does a lot of checks. So I do string overflows. You can actually see I have my cross-site scripting injections and variations in there. And there's some other things. I put my response codes. There's my default packet right there. You can see that basically you put it in a loop and try to put one packet through as many mutations as possible. There's a lot of packet delivery. You can see that's very important. Okay, so I know. I'm just skimming through it. Let me actually make sure okay, it's up. Okay, so you guys may be thinking, what is this guy doing? Shoot. Yeah, I know, right? I was here to present, not to document, I was told. All right. All right, cool. So right now I just, I forced UDP with cross-site scripting enabled, so it will only try this cross-site scripting right now. So you'll see that this is the actual Asterisk command line interface. And it's just pumping through this output. If you have a web application in your logging infrastructure, this is going right to it. You could retrieve it through a web application. If it doesn't have that egress filtering, it's going to take this direct input and put it right in your web app. So we'll just give it a minute. You'll see the attack code coming. And it goes beyond this. There's also SQL injection you could throw in there. So say your web application is vulnerable to SQL injection, you could do that too. The script also checks for HTTP response splitting. I haven't found a PBX that's vulnerable to it, but you might as well check for it. Okay, well, I'm going to cheat. So it up here. So you'll see that with certain packet combinations where you place this attack code, it comes right out, script alert, just like that. So say you have a problem. say I know I injected this JavaScript, and I want you to check it. I'll try to fault your system. I'll hit it with a DOS flood real quick. So you'll log in and check it. Bam. You just executed the code I sent you. And that's all without touching the web server. In certain implementations, it does it by itself. There's some more. So this, for me, isn't necessarily an asterisk vulnerability. This is more of a implementation vulnerability. It's the web app's fault. I've tested a whole bunch of these web applications. The one Digi makes works good. I'll give it the 2 thumbs up for that. I don't want to name any names or write any lists or anything like that. But right now, for me, I wouldn't use a web application unless I tested it. And for you guys, being able to test it effectively, this code's, I haven't released this code. If you guys are serious about testing it, you can email me and I'll send you the code to test. And the whole dissemination thing in this venue, I don't really mind. So are there any questions about those 2 examples so far, the past and the current? 5 minutes? Okay. Oh, wow. Time flies when you're having fun. Okay. Questions? Mm-hmm. Yeah, the HTML encoding. That's definitely a good route to go. But unfortunately, a lot of people do that on the ingress. They don't do that on the egress. So you have to check both. So since I have 5 minutes left, there's something I want to talk about in the future. And I'll just breeze through it real quick. There's something I've been working on. For me, SIP and HTTP are kind of like cousins, so I treat SIP like it's HTTP. So what I've been going through is writing code for a timing attack against SIP. So say, for example, I know that without authentication, I could make asterisk communicate with any IP address in the world. I can make it resolve. I can make it ask for a DNS query for any fully qualified domain name. It's just the way it goes. I could put in the packet a specific IP address. It'll send the packet response back to it. So say, for example, I could pull the data. So